Hello students, welcome to Sri Joyendra's Rank Zone classes. I am your friend and mentor for coming classes with respect to physics. This is lecture number 1 of a unit moving charges and magnetism. This is the first lecture, so let's begin with the today's class. In today's class we are going to discuss about the magnetic field. It's an introduction to a magnetic field and Lorentz force. So first let's begin with the magnetic field and then we will switch to the Lorentz force. What magnetic force is all about? Let's have a look. It says that a static charge, that means a charge at rest, cannot produce magnetic field, but only a moving charge can do it. Hence the force on a charge Q in a magnetic field B moving with velocity V can be written as F magnetic is equals to Q into V cross B. This is the cross product of velocity vector and the magnetic field vector. If I simplify this, it could be written as QVB sine theta, a unit vector n cap, where theta, this theta is the angle between velocity vector v and the magnetic field. If the magnitude of magnetic field beta, it's a magnitude of magnetic field b, is 1 SI unit, when the force acting on a unit charge, it's a 1 coulomb, moving perpendicular, it's a perpendicular to B with the speed of 1 meter per second is 1 Newton. So this is the definition of the magnetic field B. If I want to know what magnetic field is, that then can be written as F divided by Q into V. So if B magnetic field is of 1 unit, when force acting on unit charge means Q is equals to 1, force acting on unit charge is 1 Newton when it is moving with a speed of 1 meter per second perpendicularly. That's why sine theta, it's a sine 90, and that could be written as 1. I hope these things are clear. Now this is the master formula, that F magnetic, the magnetic force acting on the system, is QVB sine theta. Now let's simplify this in more another manners, that I understand that my force was F is equals to Q V B sine theta. If I write down as a magnitude only, then if I put velocity equals to 0, that means if my charge is at rest, then my force, or I should say it's a magnetic force acting on this charge, is 0, because only a moving charge fills the magnetic force. If charge is at rest, Fm is 0. This is first conclusion. Second, let's say V and B are something like this. Let's say suppose this is V and this is B. So in this case, theta between V and B is 0 degree. A same situation can arise. Could it be there if suppose this is V and this is B. Here the angle between V and B is 180 degree. So whether it is a case of a theta equals to 0 degree, or whether it is a case of theta is equals to 180 degree, the sine 0 or sine 180 would be a 0. That means magnetic force acting on the charge is 0 even though it is moving, because velocity and magnetic field vectors are parallel or anti-parallel to each other. So if V and B are parallel or anti-parallel, magnetic force would be equals to 0. Yes, one more thing, and very important, the direction of magnetic force. It is always the perpendicular to both the velocity and the magnetic field. You need to remember this, even though I'm going to summarize this, but please try to remember as many things as possible. Yes, now let's move to the complete Lorentz force. Now the force on an electric charge Q in motion due to both electric and magnetic field. Up till now whatever we were discussing was with the magnetic field only. Now what Lorentz force, Lorentz has given the force of due to both, due to electric field as well as due to magnetic field. So if I need to write down the Lorentz force. I need to write both the things. So F total, it's a F electrical plus F magnetic. The electric force could be written as Q into E, that we have know from the unit first. It's unit, it's a charges and their fields. It's a F is equals to Q into E, and F magnetic, that we know from today, it's a Q into bracket V cross P. Yes, so this is the complete Lorentz force. It says that force on a charged particle would be because of electric field as well as magnetic field. For electric field, you can write down it as an Q into E, and for magnetic field, it is a Q into V cross B. Yes, this is the Lorentz force. Now, unit of B, it's a magnetic field, it's a Tesla. And if I want to write down the dimensional formula, I can have the dimensional formula from this. It's a B is equals to F by QV. For unit, you can have this. It's a Newton divided by charge is the coulomb. Velocity, it's a meter per second. So it's a Newton into second divided by meter into coulomb. Yes, from here you can have a dimensional formula of this. Yes, we can say if magnetic field is of 1 Tesla, when force is of 1 Newton and the charge is of 1 coulomb, and velocity with which it is moving, it's 1 meter per second. Yes, yes, great. Next, Tesla can be defined as the magnitude of magnetic field when a force of 1 Newton acts on a charge of 1 coulomb moving with a velocity of 1 meter per second. This is just the repetition of the same thing, because we need to be ensured that we must know what Tesla is. Yes, non-SI unit of magnetic field, it's a Gauss. It is CGS unit. It is CGS unit of magnetic field. It's a Gauss, and 1 Gauss is equals to 10 to the power minus 4 Tesla, or 1 Tesla is equals to 10 to the power plus 4 Gauss. Yes, this is SI unit and this is CGS unit. So is it clear? Is it clear? Everything? Everything, is it clear? Are you sure? Are you sure? Okay. Let's just summarize everything, that what all we have discussed up till now. So first, the force acting on moving charge due to magnetic field is F equals to Q V B sine theta, where theta is angle between V and B. Yes, at this point of time we understood that V is the velocity of charged particle, B is the magnetic field, and theta is the angle between vector V and vector B. So from this we understood that if this is V, this is B, that means in this case theta is equals to 180 degree. Sorry, theta is equals to 0 degree. So if this is the case, my magnetic force would be equals to 0, because sine 0 degree would be equals to 0. That we understand. If the situation is something like this, this is V but this is B, in this case theta is the angle between velocity vector and magnetic field vector. It's a 180 degree, and if it is 180 degree, then magnetic force would be equals to 0, because sine 180 degree is equals to 0. This is the one of the case when V and B are there, Q would be there, but the magnetic force is 0. A third case, if V is equals to 0, that means if charge is at rest, if charge is at rest, then magnetic force must be equals to 0. Yes, because V is equals to 0. So this is independent of angle theta, whatever could be the angle theta. But if my charge is not moving, that means magnetic force acting on that charge is always 0. Is it clear? Great. Let's summarize something more, that the magnetic force was Q into V cross B. That means F is always perpendicular to V, it's a vector V, and vector B. Yes, so angle between F and V is always 90°, and angle between F and B, again it's a 90°. So F is perpendicular to V, as well as F is perpendicular to B. This is true every time, each time. You must understood this. Okay, so what else we can derive, what else we can understand from this is F is always perpendicular to V and F is always perpendicular to B. So if this is the case, that means magnetic force cannot change the speed of a charged particle. It can only change the direction. It can only change the direction of charged particle. I hope you understand this, that this is the case because F is perpendicular to V, and if force and velocity vector is perpendicular to each other, then means it cannot change the speed of a charged particle, but it can only change the direction of charged particle. Now one more thing, work done due to magnetic force, is always 0. Why this is the case? Think for a while and let me know. Work done due to magnetic force is always 0. Why this is the case? Yes, if you remember class 11 work power energy, and it's a work energy theorem. Work done was half mv square minus half mu square, as your final velocity and initial velocity would be the same, because magnetic force can change only the direction and not the magnitude. That means this should be a 0. So work done due to magnetic force, with always 0. Remember this thing, very very interesting, and this is one of the favorite corner or one of the favorite area of the examiners. One more thing, power delivered due to magnetic field. Now I understood that P is equals to F dot V. So this could be written as F V cos theta. Yes, And I understand that force and velocity are perpendicular to each other when I'm talking about the mag due power delivered due to magnetic field, or it's an, so this is F V cos 90 degree. As I understand, cos 90 is 0, so this is 0. So power delivered due to magnetic field is always 0. I need to remember all these things, each and everything. Yes, that work done is 0, power delivered is 0, that, and the magnetic force cannot change the speed of an object or change the speed of a charged particle. It can only change the direction of charged particle. Yes, this F is perpendicular to V and F is perpendicular to B. I need to remember each and everything. Yes, because these are the sections from where question has been asked. I hope these things are clear. Yes, so let's just look at the cases with magnetic force. Let's just have a look at this. It is the cases with the magnetic force. So case 1, if theta is equals to 0 degree or theta is equals to 180 degree, this is V, this is B. In this case, theta is equals to 0 degree. If theta is equals to 0 degree, my magnetic force would be 0, that we have understand from the previous slides. If this is V, this is B, that means theta is equals to 180 degree, so my magnetic force would be again 0. This is first case. Yes, in both the cases magnetic force is 0. Second case, that's a case 2. If charged particle is at rest, that means if V is equals to 0, if it is the case, it's an F is equals to Q V B sine theta. And if V is equals to 0, the magnetic force is always 0. Yes, that's two cases. Now let's discuss very very important cases. Have a look very carefully. If velocity vector V is perpendicular to the magnetic field B, if this is the case, if velocity vector V is perpendicular to B, then charged particle will move in circular path. And if this is the thing, that charged particle will move in a circular path, now let's have a look to the situation, how the situation would be. That first, for this we must understand that this is the cross sign. This sign is used to represent magnetic field is inside the plane, and this dot sign, this is used to represent magnetic field is outside the plane. Yes, these two notations are used. One represent that magnetic field. One represents that magnetic field is inside the plane, and another will represent that magnetic field. This magnetic field is inside the plane. Yes, so one represents it is an inside the plane. Another represents that it is the outside the plane. I hope these things are clear. Is it clear? Any difficulties in this? Anything? No? Okay, let's back to this case, that if velocity is perpendicular to B. So let's suppose that this is the magnetic field. This is the magnetic field, and charge particle has been entered in this with these, as you can see, that that this is the velocity vector. Let's suppose it's in V is in I cap, and magnetic field it is represented with cross, and when it has been represented with cross, that means it is in minus of k cap, as this and this are 90 degree to each other. That's why my charge particle will be moving in a circular path, something like this. Yes, charge part motion of a charge particle will be something like this. Let's suppose this is the center, this is the radius of the circular path, and charge particle is moving in this. Let's suppose the charge of the charge particle is q. So if I understood that magnetic force, or the value of a magnetic force, would be equals to qvp sine 90 degree, I understand that sine 90 is 1. So magnetic force can be given as qvb, and the centripetal force as it is moving in circular path, it would be an mv square by r, where where m is the mass of charged particle. It's a mass of the charged particle. V, velocity of charged particle. R, it's a radius of the circle. So I hope you understand that the required centripetal force to move on the circular path is being provided by the magnetic force. So I can equate this to, and if I can equate this to, I can write it's a qvp, that should be is equals to mv square by r. Yes, this is the qvb, that would be equals to mv square by r. And if I can write this, for velocity, if I want to write down the velocity, this has been cancelled, I can write it's a v should be is equals to q b r divided by m. This is the first factor. V should be is equals to q b r divided by m. Please note down this, please. Have you? Great. Now what would be the radius of a circle? I can have this, it's a r, that should be is equals to mv divided by qb. This is the radius of the circular path in which it is moving. This is r equals to mv by qb. Next, momentum, it's a r is equals to m into v. M into v could be written as the momentum, so this is p divided by qb, and from this p is equals to qbr. Look at this, this is the momentum, this is momentum. P is equals to qbr. Is it clear? Is it? Great. Now let's just find it out. Find out time period of its motion. So as we know it is moving in circular path, we can write like this, it's a t is equals to 2 pi r by v. If I replace the value of r, it is m into v divided by q into p. This v and v has been gone, and it would be 2 pi multiplied by m divided by qb. If you observe this very very carefully, then you might know that this is the angle for which my charged particle is within the magnetic field. Look at this. If you observe this charged particle, it is moving on this path. Yes. So this charged particle was in the magnetic field for the angle that is of 2 pi. So even on a generalized term you can write like this. Please remember this: T is equals to theta into m divided by q into b. This is very very important. Yes, this is the time period. Okay, so let's have a frequency as well. Frequency, it is a 1 by t, and 1 by t that could be written as qb divided by 2 pi m. This is the frequency. Yes. Next, find out kinetic energy of the charged particle. How will you evaluate it? It's a kinetic energy which should be is equals to half into mv square. Yes, that could be written as m multiplied by v square. What is v? It's a qbr by m. It's a square. So this is equals to half into m multiplied by q square b square r square divided by m square. So this is equals to q square b square r square divide by, here it's a m to the power 1, it's a m to the power 2, it's a cube square b square r square divided by 2m. This is the kinetic energy of charged particle. Even you can go with this. It's a kinetic energy which should be is equals to p square by 2m. This p represents the momentum. P is equals to qbr. It's a q square b square r square divided by 2m. Probably this is the shorter approach. Yes, this will make our task fast. Yes, if you remember this, very good. I hope these things are clear. Is it clear? Is it? So if I want to write every relations, then it's a radius which could be written as mv by qb. It's a velocity which could be written as qbr divided by m. It's a momentum. It's a momentum which could be written as qbr. It's a time period which is equals to theta into m by qb. Yes, it's a frequency. If it's a q into p divided by 2 pi m, and it's a kinetic energy which could be written as q square b square r square divided by 2m. Yes, this all are the relations. Yes, you must remember this. You must remember this. I hope these things are clear. Is it clear? Any doubts on this? Anything? No? Great. One more thing, and we will move straight to the question answers. Let's have a look that we generally used to deal with 4 particles. One is the proton, next it's a deuteron, next it's a tritium, and next it's an alpha particle. Generally, let's write down their charge and mass. For proton, if I write that charge is the q and mass is the m. For deuteron, charge will remain the same, mass is the double. For tritium, charge is the q, mass is the 3m. And for alpha particle, charge is the 2q and mass is the 4m. I hope you understand that from where I have written this. It is just alpha particle, it is the helium particle which we can write as a 2He4. And in chemistry you understand that this would be the Z, this would be the A, this Z represents the atomic number, and A represents the atomic mass. Yes, so it's a proton, it's a 1h1. For the deuteron, it's a 1h2. For the tritium, it's a 1h3. Yes, and alpha particle already written, it's a 2he4. I hope these things are clear. Yes, please do remember this thing. Please do remember these things. So, are you ready with the questions? Have you noted down this? Have you? Have you noted down this? Are you sure? So, are we ready with the questions? Let's have a look. That if proton and alpha particle are moving with same velocity and entered into uniform magnetic field perpendicularly, then find out ratio of their first r1 is to r2, it's a radius. Second, velocity 1 is to velocity 2. Third, momentum 1 is to momentum 2. Fourth, time period 1 is to time period 2. Next, frequency 1 is to frequency 2. And the sixth, it's a kinetic energy 1 divided by kinetic energy of 2. Yes, this is all what we required. Now go through the data very carefully one more time. What does it say? It says that proton is there and alpha particle is there, are moving with the same velocity. Great. That means they says that velocity 1 is equals to velocity 2. So this has been resolved. It's a 1 is to 1. Yes, velocity is the same and entered into uniform magnetic field. That means both have been traveling in the same magnetic field. This is the first data, this is the second data, and the third data. Perpendicularly, that means theta is 90 degree. I am talking about the V and B. Yes, so it means it is moving on the circular path. Yes, this is all what we understood up till now. Now, what I need to do, I need to find out the radius. How could I do this? Let's have a look. The radius, which would be equals to mv by qb. Here in this case, I understood that velocity is same, b magnetic field is same, so this radius is proportional to m by q only. So let's say it's a r1 is to r2, it's a mass 1 by q1 multiplied by mass 2 divided by q2. I hope these things are clear. Now what which two particles do I have? I am having a proton and I am having an alpha particle. So mass of a proton, it's an m. Mass of an alpha particle, it's a 4m. Charge of an alpha particle, it's a 2q. And charge of an proton, it's a q. So this has gone, this has gone, this is 2 is to 4, which should be a 1 is to 2. I hope these things are clear. Is it clear? Yes. So this is the radius. Now I have done with this. I am already knowing this. Let's move for the momentum. Momentum P is equals to Q into P into R. Yes. So it's a they are moving in the same magnetic field. So P is directly proportional to the Q into R. So let's find out the P1 is to P2, which is equals to Q1 R1 divided by Q2 R2. A first particle is of proton, and when it is a proton, it is a charge of Q. Second particle, it is of alpha particle, so that means it would be of 2Q multiplied by radius 1 is to radius 2, it's a 1 is to 2. This QQ has gone, and this would be equals to 1 is to 4. I hope these things are clear. Yes, so you have done this. About the momentum. Yes, about the momentum, it is a 1 is to 4, and radius 1 is to radius 2, it's a 1 is to 2. I hope this things is clear. Now let's move for the T1 is to T2. The time period, here it is moving in the complete circular path, so I have written it's a 2 pi m by qb. Yes, they have been traveling with the same magnetic field, and 2 pi remains the same, so I can write it's a T which is directly proportional to the mass to the charge. This is proportional to the mass to the charge. Is it clear? Yes, so this is T1 is to T2, which should be is equals to mass 1 divided by Q1 multiplied by mass 2 divided by Q2, which could be written as M1 is to M2 multiplied by Q2 is to Q1. Mass 1, it's an M. Mass 2, it's a mass of an alpha particle, which is of 4m, multiplied by charge 2. It's a charge of an alpha particle, which is 2q. Charge of the proton, this is q. This has gone, and this is 1 is to 2. It is same as the radius. It is same as the radius. So this is T1 is to T2. Frequency, it is just the inverse of this, so it should be 2 is to 1. I hope you understand this very well. So you have done with the time period. You have done with the time period. Now let's just find it out, the last requirement of ours. It's a kinetic energy, which is p square divided by 2m. Yes, I have opted the momentum because I know the ratios of the momentum and I need to look for the mass only. So let's write it down. It's a kinetic energy 1 divided by kinetic energy 2. This is equals to p1 square divided by p2 square multiplied by m1 divided by m2. This is the case. Yes, so p1 is to p2. If you remember this, it's a p1 is to p2. It is a 1 is to 4. So this is the square of the 1 is to 4 square multiplied by mass of an alpha particle, it's a 4m. Mass of a proton, it's a m. This has gone. This is 1 is to 16 multiplied by 4, which would be 1 is to 4. I hope you got the same as an answer. Is it same? Is it? Great. So can you do this kind of questions? Can you? Is it possible by you guys to make it done? Are you sure? Can it be done? Can it be? Great. So ready for the next question? Shall we? Shall we move to the next question? Okay, great. Let's move to the next question. If charge is of 2 microcoulomb is moving with a speed of v is equals to 4I cap plus 2j cap plus 3k cap in a magnetic field of B is equals to I minus 3k. Find force acting on charged particle. This is the requirement. How will you do it? How will you do it? So I understood that F could be written as Q into bracket V cross P. So let's just evaluate V cross P, and then I will go to multiply with the charge. It's a 2 microcoulomb. So let's just find it out. Initially, the V cross B, So that could be written as this is equals to I cap, J cap, K cap, V cross B. So it's a coefficients of V, it's a 4, 2 and 3, and then it's a B. So please remember this is I cap, so 1. Here no J cap is there, so you need to write 0 minus of 3 K cap. Yes, this was the situation. So that could be written as, this could be written as I cap multiplied by. So if I am going to write I cap, I need to forget this. It's a 2 into minus 3, which is of minus 6 into 0. Doesn't make any sense. Minus of J. This is minus of J. So when I write J cap, I need to forget this. It's a 4 into minus of 3, which is of minus of 12, minus of 3. Now plus K cap. When I write the K cap, I need to forget these things. So it's a 4 into 0, which is a 0, minus of 1 into 2, it's a minus of 2. So this is equals to minus of 6I, minus 12 minus 3, it's a minus 15, minus plus, it's a 15 of J cap, minus of 2K cap. This is the V cross B. I need to multiply this with this Q. It's a 2 into 10 to the power minus of 6 multiplied by V cross B. It's a minus of 6I plus 15J minus of 2K. So that could be written as, 2 6 are minus of 12 I cap plus 15 into 2 plus 30 minus 2 into 2 minus of 4K cap into 10 to the power minus of 6 Newton. This is the force acting on the charged particle during its motion within the magnetic field. I hope this is clear. Is it clear? Is it clear? Great. So now are you ready for the one question, a logical one? Are you ready? Great. Let's have a look. The question says that a charged particle moving in magnetic field B is equals to I minus of J Tesla has an acceleration of 2I cap plus alpha J cap at some instant. Find out value of alpha. Yes, think for a while and let me know what we can do for this. It says that a charged particle is there which is moving in magnetic field B, which could be given as I minus J Tesla. It is having an acceleration A is of 2I plus alpha J at certain instant. We need to find out the value of an alpha. How could I do this? Any idea? Yes, some of you might get this. That we understood that when charged particle is moving in magnetic field, I know that force is perpendicular to magnetic field. And while I say force is perpendicular to magnetic field, I must understand that it's an acceleration, or it's an acceleration due to magnetic force must be perpendicular to magnetic field. And if these two are the perpendicular, I can write down that dot product that could be equals to 0. That means it's an A dot B should be equals to 0. And if it is 0, I can have like this, it's a 2I plus alpha j multiplied by I minus of j, and this could be written as 0. Yes, so it's a dot product, product of I with I and product of alpha, product of j with j. It's a 2 into 1, 2, plus alpha into minus of 1, minus of alpha would be equals to 0. So this alpha is equals to 2. This would be the answer. You did it. Great. I hope the things are clear. Is it clear? Is it? So up till now, are you comfortable with this? Yes. So we have look with the three cases. Ideally, it's a fourth cases. Yes. So if you remember this, look at this. This is the first case if theta is equals to 0 or 180 degree. This is the case number 2 if velocity is 0. And then we have switched to the third case. Very important, if v is perpendicular to b. Yes, these three cases we have discussed up till now. Are you comfortable with this? Are you? Are you comfortable with this? Great. So now let's switch to the next case. It's case number 4. That if velocity is making an angle theta with magnetic field B, and when I say that velocity is making an angle theta, velocity is making an angle theta with the B, then I'm talking about that theta could not be a 0, theta could not be a 180 degree. Yes, but this theta would be the, this theta will be the acute angle. So the situation would be something like this, that let's suppose this is the magnetic field and I'm going to project my charge particle with this. This is the angle theta. Yes, so when this is the situation, that B and V have an angle theta between them, so my charge particle will be moving like this, that it is something like this. This is the helical path. I hope you understand this. Yes, this is the helical path, and if I take any one of the circle, if I take, technically this should be called as an helix. Let me write this. It will follow helical path first. This is the radius r, and the distance between two consecutive helix, this can be represented as the pitch. It's a distance between two consecutive helix. It is the pitch is the distance between two consecutive helix. Yes. So what I can now write, what I can write down, tell me. Let's look at the situation, that this is the B, this is the theta, this is V. So if I make a component of V, this component would be the V cos theta, and this component would be the V sin theta. So what is the radius of the helix? Radius of the helix, so R could be written as mv sin theta divide by q into b. Yes, previously it was R is equals to mv by qb. So even at that position, it was the V perpendicular. Here the V perpendicular is V sine theta. So I have written it's an R is equals to mv sine theta divided by Q into B. Now, next, what is the pitch? It is the distance between two consecutive helix. And when I write down the helix, or when I write down the pitch, I'm talking about the horizontal displacement. And for the horizontal displacement, the responsible velocity should be the horizontal one. It's a v cos theta multiplied by time period. This is v cos theta multiplied by 2 pi m divided by qb. This is the distance between two consecutive helix, and that we call as an pitch. From here, you must understood that time period of this situation. Time period of this situation would be the same. It's a 2 pi m divided by qb. So, are you done with this? Are you done with this? This is the fourth case. This is the fourth case when charged particle is entering the magnetic field with certain angle theta, and this theta would be the acute angle. So have you noted down this all? Have you? Are you sure? So ready for the question? Let's have a look. This is the magnetic field. This is the velocity vector. This is the angle 30 degree. If charged particle Q enters magnetic field B as shown in the figure, find out first radius, second trajectory of charged particle, next pitch. At this point of time you are interested in this much thing only. Yes, so let's begin. First radius, it's an mv sine theta divided by q into v. This is equals to m into v into sine theta. It's a sine of 30 degree. Have you remembered this? If no, then this was the situation. This is b, this is v, this was the 30 degree. Yes, so this is mv sine theta divided by q into v. Sine 30, it's in half, so this is mv by 2 qb. This is the radius. Next, the path or the trajectory of the particle is helical. Second answer. Third, they were looking for the pitch. So the pitch is v cos theta multiplied by 2 pi m divided by q into b. This is v cos theta multiplied by 2 pi m divided by qb. So that should be v multiplied by cos of 30 degree multiplied by 2 pi m divided by qb. Cos 30 could be written as root 3 by 2 multiplied by 2 pi m divided by qb. This 2 and this 2 has been gone, and whatever I am left with, it's a root 3 pi mv divided by q into b. This is the pitch. Yes, it's a distance between two consecutive helix. It is the distance between two consecutive helix. I hope these things are clear. Is it clear? Is it clear? Are you sure? Are you sure? Okay. Shall I add something very, very interesting to this? Shall I? Let's have a look. In the previous question, find out ratio of circumference of helix to the pitch. Yes, go through the question very carefully. What does it say? It says that in the previous question, find out ratio of the circumference of helix to the pitch. So circumference of helix can be written as it's a 2 pi r, and r can be written as mv sine theta divided by qb. Yes, and the pitch can be written as this is equals to v cos theta multiplied by 2 pi m divided by qb. So now let's just take the ratio. Circumference of helix, let's denote it as a c and pitch as an x. So let's write it down. C is to x. The c should be is equals to 2 pi multiplied by mv multiplied by sine theta divided by q into b. The pitch could be written as it's v cos theta multiplied by 2 pi m divided by q into b. Let's just try to solve this. It's a qb has been cancelled. This is 2 pi, this is 2 pi, this m and m has been cancelled. So again this v and v has been cancelled. So this is equals to sine theta by cos theta, which should be tan theta. So this is the ratio of c is to x, circumference of a circle, or of obviously as an helix, to the pitch. So this is c by x, which could be written as tan theta, and according to this question it should be an tan 30 degree. Yes, it's a c by x, which is equals to tan 30 degree. And if it is the case of c by x, which is equals to tan 30 degree, then I know the value of tan 30. What is it? What is it? It's a 1 by root 3. Yes, so I can write like this. It's a c, that means circumference of the helix is 1 by root 3 times of the pitch. This is equals to c is equals to x by root 3. I hope these things are clear. Is it clear? Is it any difficulty in this? Anything? So can you solve this kind of questions? Are you sure? Can it be done? Can it be? Can we do this? Are you sure? Okay, great. Let's just wind it out this session over here. In this session we were discussing about the magnetic force that is acting on the charged particle when it is in motion. Yes, from the next session, in the next lecture, we are going to discuss the same magnetic force with certain different cases and the direction of this magnetic force. Yes, so I request you guys, please go through this session very, very carefully, and before you tune on to the next lecture, please be through with this. Yes, thank you. Have a good day. Take care. Bye bye.